So you're going to definitely get one question on finding the solubility product, the KSP value. And these formulas or these notes in italic are from your reference handbook. They're on page 85 of your reference handbook, towards the center above Faraday's equation. So solubility is represented by as a capital S. It's the maximum amount of a substance that will dissolve in a given amount of solvent. So what you're going to find in a problem statement is you're either going to find a KSP value or a capital S value. So if we look at this form of a substance AB, AB, if dissociated, is going to form A plus ions and B minus ions. These subscripts here, they correlate to the stoichiometric coefficients in the ions, and they also correlate to the charge of that ion. So it's kind of interchanged here, right? M and N plus, N, and M minus. So once you determine this A plus and B minus concentrations, you can plug those into this formula to find your KSP value. So if we remember, brackets represent molar concentration, moles per liter. So the molar concentration of A plus ions raised to the M power times the molar concentration of B minus ions raised to the N power gives you your KSP value. Your KSP is unitless, just like your K sub C, K sub P we went through yesterday. And the best way to go through this is to go through an example. But before we get to an example, the one thing you should know for the exam is how solubility changes versus temperature in solids. And you should know the general trend. So for most solids, solubility increases as you increase the temperature, right? For most solids. But then you have your exceptions like salt and cesium sulfate, where the solubility is not affected by the temperature increase. But if they ask you on the test, generally, what is the relationship between solubility and temperature for solids, the answer would be they're proportional, meaning as you increase solubility, as you increase temperature, solubility S increases. Now, they can ask you this about solids, and they can also ask you about gases. So if you look at this graph, and you can find similar sort of graphs online or in other college textbooks. This is from that textbook I referenced in the references slide. So as you increase temperature, the solubility of gases, for some gases, most gases decrease, right? Even these two, O2 and N2, they start off decreasing at the beginning, the solubility, and they eventually taper off here. So the general trend is as you increase temperature of gases, the solubility decreases.